Hello math learners! Welcome to our part 2 of the discussion how to write polynomials in factored form. But before anything else, hit that subscribe button and notification bell for you to be updated of these cool clear math videos just like this. Hello math learners! This is still your free access math teacher Ash, and today we're going to continue our first discussion on writing polynomial functions in factored form. As you can see, we have our first two examples. Y is equal to 3x cubed plus 6x squared plus 4x plus 8, and the second one is y is equal to 45x cubed plus 18x squared minus 5x minus 2. Okay, now for me as a solver, first thing that I look in getting the factored form of a given function is to check are all of the terms complete in their own exponent. So as you can see, this is cube, squared, linear, and then constant. So all of the terms are complete. Now if this is the case, what I need to consider is the process of grouping. Okay, so the first thing I will do is I will group the first two. Okay, I will group the first two. And then, I will check it whether I can extract a common factor from each group. So, 3 and 6, what is the common factor? Okay, that is 3. Now, x cubed and x squared, what is the common factor? Okay, that is x squared. So, if I extract 3x squared from this first binomial, this will become x plus 2, because 3x cubed divided by 3x squared, that is x. 6x squared divided by 3x squared, and that is positive 2. Okay, how about this side? What is common between 4x and 8? The common factor is 4. Okay, so I will extract positive 4. Now, if I extract positive 4 from this term, this will become x. And if I divide this by 4, this will become positive 2. So as you can see, there is a common factor from the first group to the second group. So I will take that as 1. And then, the outer terms or the outer factors, I will also put them into one binomial, and that will give me 3x squared plus 4. So therefore, I have now my factored form for this given polynomial function. Easy, right? So that is how you get the factored form of the number 1 example. Now, let us go to number 2. We have here 45x cubed plus 18x squared minus 5x minus 2. So, the terms are also complete. We have the cube, the squared, the linear, and the constant. Okay, so I'll try to use my grouping method. Okay, so now what is common between 45 and 18? I think that is 9. What is common between x cubed and x squared? That is x squared. Okay, so now I will try to extract 9x squared from this binomial, and that will give me 5x plus 2. So if I multiply this, so this is just the checking. 9x squared times 5x, that is 45x cubed. 9x squared times 2, that is 18x squared. Okay, I'm correct. Now, how about this one? What is common? So, 5 and 2, there is nothing common except 1. But since both are negative, I will extract negative 1. Okay? So, if I extract negative 1, this will become 5x. And negative 2 divided by negative 1, that will become positive 2. So as you can see, I again have a common factor, that is 5x plus 2, and I will group them as 1, and also I will group the 9x squared and the negative 1 as another factor. Okay, now look at this. As you can see, the first factor or the first binomial is a difference of 2 squares. Why the difference of 2 squares? Because 9x squared is a perfect square and 1 is a perfect square. Remember in the lesson, special products, if you have a difference of 2 squares, you can factor them by getting the square root of each term that is a plus b and a minus b. So we have, for 9x squared minus 1, this will become 3x plus 1 and 3x minus 1 plus the other group or the other binomial. So now I have the complete factored form of the second given polynomial function. Easy, right? So I suggest, my dear math learners, that when you factor your polynomial functions, always try to think and to see your given solution whether you can still simplify it to its factored form, such that this example. Okay, so now let us have 2 more examples. Okay, math learners, we have here 2 more examples for our lesson in the part 2 of writing polynomial functions in factored form. First one is f of x is equal to 81x to the 4th minus 16, and the second one is f of x is equal to x to the 4th minus 4x squared minus 45. Okay, now as you can see in this example, the terms are not complete. What do I mean by this? This is x to the 4th. We don't have x to the cube, x to the second, the x. We only have the 4th exponent, or the power of 4, and we also have the constant term. This is an example of a quartic polynomial function. Now, how do I solve this one? Okay, now if you have a quartic, a quadratic, or a power of 2, or a degree that is compatible to 2, then you can apply what you have learned in the quadratic functions. So, as you can see, this is difference, right? Because this is subtraction. And this term has a square root. Also, this term, 16, has also a square root. So, we can apply what we have learned earlier in example number 2. So, I could just make 2 quantities, okay? That is positive and negative. So, the square root of 16 is 4. So, I'll just put 4 here and 4 there. Okay. Now, that is positive and negative because our resulting sign is negative. Okay. How about 81? That is 9. And x to the 4th is x squared. This is x squared. Okay. Now, as you can see, this cannot be factored even further. However, this one can still be factored such that this is again an example of the difference of 2 squares. So we can still continue our solution. So we have 9x squared plus 4. Then we will have another plus and minus here. So the square root of 4 is 2. And the square root of 9x squared is 3x. And now I have the final answer for my factored form. Easy, right? So that is how you get the factored form of this given polynomial function. Now let's go to our final example, and this is x to the 4th minus 4x squared minus 45. So in this example, as you can see, this is a trinomial. Now, remember in our lesson in trinomial, there are a lot of ways to solve the trinomial. You can use the sum and product pattern. You can also use the grouping method. And also, you can also use the perfect square trinomial. That is if your factors are identical. Now, let's try to see this one. X to the 4th minus 4x squared minus 45. Now, in our general trinomial, we have a power of 2, right? And this is x to the 4th. This is x squared, and this is the constant term. So basically, if we check our terms, we don't have any x cubed and we don't have any x, or that linear term. We only have the 4th power, the 2nd power, and the constant. Okay, so for me to not have any problems about this, I will consider first using the let. Okay, I will let x is equal to x squared. Okay? I will let x is equal to x squared. What do I mean by this? If I see x squared in my given equation, I will change that into x for the time being. Okay? So, now, this will become x squared minus 4x minus 45. Now, you might be asking me, why did this become x squared? Remember that x to the 4th has 2 x squared. Okay, 2x squared. That is x squared and x squared. That will become x to the fourth, right? So therefore, if this is represented by x, then I will have 2x's giving me x squared. See the pattern? Okay. So, my representation is very important. Okay. So, by continuing, I can easily factor this one. So, x squared minus 4x minus 45 is just a quadratic term. So, I can now use the general trinomial method. So, I will just make two factors. This is where the sum and product goes. So, I will factor x squared. That is x and x. Okay. And then, I will factor negative 45 such that when I add them, the answer is negative 4. Okay, so what are the factors of negative 45? I have negative 9 and I think positive 5. If I multiply these two, negative 9 times 5, this will give me negative 45. If I will add them, this will give me negative 4. Okay, I'm correct. So therefore, I will use negative 9 and positive 5. Okay, now, as you can see, we cannot factor this anymore. But the question is, are we finished with our solution? My dear math learners, not yet. Why? Because we made a representation earlier. So now, we will return our representation to its original form. So now, this representation will be entering in this final part of your solution. And this will become, the x here will become x squared. So that is x squared minus 9. And this will become x squared plus 5. As we can see, x squared plus 5 is a binomial that cannot be factored. Okay, so that is already the final answer in this part. However, x squared minus 9 is a difference of two squares. Therefore, I can still factor this out by using x plus 3 and x minus 3. So giving me three factors, x plus 3, x minus 3, and x squared plus 5. And this is the final answer for my factored form in this given polynomial function. Easy, right? So, I hope you have a wonderful time about our topic for today. Now, this is the time that I will challenge you whether you have understood our topic for today, and here it is. Okay, math learners, I hope I have helped you in your endeavor in answering your modules about this topic. This is still your free access math teacher, Ash. And always remember, it is fun to learn mathematics if we are together learning. Consider subscribing, clicking that like button, and sharing this to your classmate friends if you think that this video or our videos in our channel could help other people. Thank you, God bless, and keep safe always. Congratulations, math learners, for arriving to this part of the video. If you think that this video have helped you, click that like button. And if you think that this channel can change the way you see mathematics, do not forget to click that subscribe button and notification bell. Thank you.